Here you can see me bike in a circle. Why, may you ask? Well, today we'll be discovering the science of turning on a bike. How can I do it, may you ask? Well, you need to lean in when you turn. Here you can see me going real fast and leaning into my turn to help me turn. Is turning on your bike and turn in your car the same? Well, no, unlike in the car, where turning the steering wheel will merely change the direction of the motion. Turning your handle of your bike will actually make you lean in into your turn and help you. And what's gonna happen if you're a fool like Kivash and don't lean in? Oh, you fall!
Trust, this is great and all, but let's dive into the actual physics behind turning a bike. When you turn a bike wheel to the right, the wheel goes to the right out from underneath you and the rest of the bike. So now you find yourself leaning to the left, and the force on the bike from the ground is directed to the left, and so the leftward force makes you go to the left. And that's how you make a left-hand turn on a bike, by first turning right. To make a right-hand turn, you should have started by counter-steering to the left. Here's a free body diagram to help. In this free body diagram, it's important to note what everything represents. Theta is the lean angle. R is the radius of the turn measured from the center of mass. AC is the centripetal acceleration of the center of mass of the bike or ride system. M is the mass of the bike or ride system. G is the acceleration due to gravity. L is the distance from point G to the effective point of contact, P, between the bicycle and the ground. N is the normal force between the bicycle and the ground. And F is the friction force between the bike and the ground in the direction of AC. Since there is no acceleration in the vertical direction, the sum of the vertical forces is zero. Thus, normal force is equivalent to mass times gravity. Apply Newton's second law in the horizontal direction. F equals mac. M equals v squared over r, where v is the velocity of the bike around the turn. Then you must sum the moments about point G. N sine theta times L minus F cosine theta times L should be equivalent to 0. Lastly, we combine the three equations above to find an expression for the angle of lean theta. We should get tan theta is equivalent to v squared over rg.